Hello again. I'm Dr. Lex.
And I'm Dimos, Dr. Dimos.
And we're the hosts of Luxi, and it's Friday. So what time is it?
It's Drinkorama time.
And it's science sip
Science
time.
sip time.
Cheers.
I need a drink.
Yeah.
Martinez.
Yeah, so this is the Autos Athens Martinez. You would think we would be sponsored by them, but we're not. We just happen to like the vermouth. And they have a series of recipes on their website, so we are just slowly going through them. So
all the red drinks.
Well, it's a very pink, here we can show, it's a very pink bottle.
It is.
So I think you make a red drink kind of no matter what.
I'll take it.
All right, so what science do you have for us this week, Dimos?
Well, I always do love talking about electric cars, and I was interested in some of the recent recalls that are occurring from a couple of the German manufacturers, including Volkswagen, on batteries that are self-discharging too much in electric cars. It causes batteries to overheat, and it also causes batteries to only partially discharge and only part of the battery. So that means the other part of the battery is good, then the other part isn't, and the battery management system in a car has a hard time dealing with that. So it's better to just take it back and have it rebuilt, or even have the batteries replaced.
Wow.
It's a big recall.
Yeah, that does sound like it would be very expensive.
Yeah. Really what it did is it made me go down a little bit of a rabbit hole as to what the chemistries are in the batteries. And
we've done a little bit about battery chemistry. Was it Diamond? Was that the episode that we went to start talking about solid state? No, rubies.
Yep.
Solid state lithium ion batteries.
And
maybe it was so?
Well, the other thing we talked about was solid state diamond, like we make transistors out of diamonds, believe it or not. They're doped. And I know we talked about that because that was actually some research I funded.
Cool.
Yeah. What I was interested in was why would that happen? And it's one of the things that we find out about lithium batteries. There's a lot of salts in lithium salts, manganese salts, cobalt, iron, aluminum, and titanium. And those salts can be formed on the electrodes on the anode or the cathode. And apparently manufacturing processes are really difficult to control. So you can have a place where maybe a little extra heat might have been part of pressing those various chemical elements and salts together to form like a lithium, manganese, cobalt cell separator or even a cathode layer. And that layer can have a thermal situation which causes the salts to be incorrectly spread.
Oh. So basically it's patchy.
It's patchy. And the patchiness can result in tiny mini batteries being formed due to the lack of uniformity of
So it's
the
like when
salts.
you're trying to spray peanut butter on a really soft piece of bread and you end up with all the patchy spots.
Yes, and those patchy spots let the jam leak through.
Such a shame.
And
you have a soggy PB&J.
And that's the jar, and that's a jar, and you can tell because there's like a spottiness on the outside of the sandwich.
Yeah. So can you see that visually in a battery, or can you just tell by performance?
If you're doing battery, and this is actually one area where sort of advanced manufacturing can help. Like for example, charge and discharge the battery while it's on the factory floor, not rolled up into a loaf, but spread out, because normally they like roll them into cylinders.
And that's how you get the shape.
Yeah, that's how you get this. It's the shape, exactly.
I didn't realize that. For some reason, I just thought that you had to make them that size, but I guess it's more of a function of fitting them into the engine.
Yeah, it depends. Like, so batteries can also be formed into flat cells, and I have some here in my workshop. And when they're in a flat cell, they can actually be that flatness. They're made like a peanut butter and jelly sandwich, exactly. And then you just have multiple sandwiches stacked, and that's how you get your voltage. Those are multiple ways of making batteries, but the roll, for example, is how the Nissan Leaf has its battery arranged.
So are they working on making batteries more reliable for EV vehicles, given how many car manufacturers are switching to that platform?
Yes, I think so, and that's part of the Gigafactory issues. But even to this day, there's still recalls and there's still issues with electric vehicle batteries not being completely consistent, and I think a lot of it is just the growing pains that we're going to have for probably next decade, as we really ramp up battery production, probably beyond what we would like. Like we're trying. I think they're trying to build them a lot faster than they can really do it.
Right.
Yeah, and that's just part of getting the costs down too.
Interesting.
Mm-hmm.
Cool.
Yeah.
I have something actually not that different.
Really? Tell me more.
Well, I'm going to be talking about a dish of brain cells that learned how to play Pong.
I heard about this.
It's very cool. So this is work out of Cortical Labs in Melbourne, and the dish that they make is called Dish Brain. So they
What a great name.
I know, right?
Dish Brain.
Very literal. I mean, it's a scientist after all. Sometimes we don't name things well.
That's as literal as it gets.
So they take mouse cells from mouse embryos and human cells that were derived from stem cells, and they grow them on a micro electrode array. And so you can stimulate the cells on this array and read the activity. So in order to get these cells to play Pong, electrodes on the left or the right would tell the dish brain what side the ball was on. And the distance from the paddle was indicated by frequency of the signals.
Oh, wow.
And then the feedback by the electrodes taught the dish brain how to return the ball.
No way.
And then the cells acted as if they were the paddle. And this is a really big thing. It's sort of biological AI in a way.
Yeah.
And it's the first, like there's been a lot of, we call them in silico or in vitro or ex vivo models of neurons to do testing. But this is the first one that has interacted with its environment this way. Yeah. And so they can sense and act on their world.
That's creepy that a petri dish full of neurons can
play Pong. Well, but I mean, think about it. A petri dish full of cardiac cells will start beating, and then they'll all start beating in synchronicity.
That's pretty amazing.
Right, so you don't need the full complex organism for some of its constituent parts to do their very basic jobs.
So we don't have a conscious petri dish?
No, I don't think so.
Okay. But there are the elements of logic occurring.
The elements of reacting to stimuli in the world.
Well, everything reacts to stimuli.
Yeah, I don't know if I call it logic. It's more of a stimulus reaction.
Okay, yeah.
But they can, so the next thing they're going to do is they're going to put alcohol on these brain cells and see if it impacts these cells' abilities to play Pong. And I'm suspecting, since this is what happened with me, every time I used to go out when I was younger, I'd have a magic sweet spot where I had like maybe a drink or a drink and a half, and my pool playing abilities were fantastic. But as soon as I got to 2 drinks, it just went downhill from there. So it'll be interesting to see if like the dish brain gets a little bit better after maybe like a little bit out, and then just gets worse.
Is there, I think though with the pool brain, like, well, dish brain versus pool brain, like if you're playing pool, you're probably a little inhibited, you're a little self-conscious, about your pool playing ability. No, you can kind of loosen up with a drink or 2.
I don't know. But what they really want to use this interactive brain dish for is to test drugs for neurodegenerative diseases.
No kidding.
Yeah.
How cool is
and they're
that?
trying to move away from using animal models. So this is maybe a way that they can have less animal testing, which I know some people, really don't like that aspect of medical research. It's actually, most people don't like it, even the researchers. Some people are very passionately opposed to it.
Yeah.
So yeah, I just thought that was super fascinating. And there's a video both explaining how it works and then of the actual Pong. I mean, you can't see the cells, but we'll post that on our Instagram page so everyone can see, and with a link to the article, because it's really fascinating.
I'm fascinated.
Yeah, I thought it was pretty cool. And then one parting thought. The state of Florida in the US has decided to make a policy against males 18 to 39 getting vaccinated with COVID vaccines based on one, not even publication, but one study. I say that loosely.
Like from Dr. Oz or something?
No, so this is part of the problem with this study. It has no authors.
Oh no.
It was not peer-reviewed anywhere.
So it's considered science?
They are considering it science. They double counted deaths. They did not verify their cardiac diagnoses with medical records. It has a very small sample size, and that's just a few of the methodological issues with it. And it's not a way to make policy. It's not science-based. It's not data-based, because that's not how you do science.
Yeah. Science is about not being partisan or not trying to lean in a direction. It's just about trying to get the facts straight and to make it transparent.
Well, you wouldn't make policy on one unpublished, unpeer-reviewed, non-authored paper with a very small sample size. So there was a study recently, a very large study. It was a meta-analysis. It was a combination of a bunch of different studies together that actually had 58 million people in it over the entire COVID pandemic, that shows that there's a small risk of myocarditis with the COVID vaccine. However, that risk is increased 7 times if you actually get COVID. So getting the virus, you're much more likely to get myocarditis than if you got the vaccine. So
if you have a predisposition for myocarditis, it's possible that there's a small chance that getting the vaccine could accelerate that predisposition.
You know, I don't know that they've actually. I don't think they've actually.
So not even that.
It's just this is overall population risk.
Yeah, but you could say if you have also predisposition to extreme respiratory distress, you could potentially have an issue with the COVID vaccine.
I don't think so.
Okay, all right.
I don't.
Yeah.
That's completely different from what the
it's a
cardiac.
different argument. But I'm just talking about the cause and effect of, because I know a lot of people have asked me about cause and effect of the COVID vaccine. Like, if I'm older and I'm sick, maybe I shouldn't take the COVID vaccine because I've heard it makes people have a side effect.
Yeah, but side effect is different from a pathology.
Okay.
This is very important. Okay. So side effects of the COVID vaccine, headaches, fatigue, fever, maybe a little scratchy throat. That's not a pathology. It's not causing damage in your lungs. That is the innate immune response of your body doing what it's supposed to do and calling the troops to order and giving you generalized symptoms.
Okay.
Fever, a little bit of fatigue, that sort of thing. It's really different from actually having an upper respiratory infection where there is a virus and it is in your lungs and it is causing damage.
Yeah.
And you're more technically correct, your immune system is causing damage.
Okay, yeah, that's fair enough. It is the immune system that you're kind of working against then, not an active virus.
Well, both. Okay. Yes, there's an active virus in your body that's an eliciting immune response that could potentially cause some damage to your lungs. So the point was not actually to go into the pathophysiology of the COVID vaccine. The point was to say that this study that the Florida Surgeon General is touting does not equivocally say that there is a significant increased risk of myocarditis if you get the COVID vaccine, and it is not a study that should be making policy decisions on. If you want more information, there's a really great resource. It's called Unbiased Science. They have a podcast, they have an Instagram page, they have a website.
Sounds like a good listen.
It's 2 scientists, a public health researcher and an immunologist, and they go strictly by the data. They have great infographics and things if you want to share those out. So give them a follow, look at the research, and get vaccinated. All right, we hope you have a wonderful weekend. We're going to finish our cocktails.
Yes, and talk about getting vaccinated.
Cheers.